Good evening all. I would like to welcome you all for the third day of AICT Training and Learning Atal Academy sponsored 2-week faculty development program on power electronics application to renewable energy system, electric vehicle and intelligent control. The offline session starts by next week by 17/10/2022. All are invited to attend. We are going for industrial visit on the first day itself. Company name is EV Nexus Private Limited, Nanganallur. The session will be followed by Mrs. Sasikala, co-coordinator of this Atal FDP. She will continue the session by reading the short bio of today's distinguished speaker, Dr. D. Lakshmi. Over to Sasikala, madam.
Good evening all. Today's session speaker is Dr. D. Lakshmi. Dr. D. Lakshmi is presently working as an associate professor, Department of Electrical and Electronics Engineering, in the Academy of Maritime Education and Training, Chennai. She received a BE Electrical and Electronics Engineering from University of Madras in 1999, ME Power Systems from BSA Crescent Engineering College, Anna University, Chennai in 2006, and the doctoral degree from Anna University in March 2018. Having 21 years of teaching experience, she started her teaching career as lecturer in 1999, promoted as assistant professor, senior assistant professor, and associate professor. She has published over 39 national, international journals and nearly 25 national and international conference proceedings. She organized many national conferences and faculty development programs. She was a keynote speaker in World Book of Record London, longest 150 hours conference, and a session speaker in various engineering institutions. She has received Senior Educator Scholar Award in 10th National Teachers Day Awards 2019 from NFED Association Coimbatore and Dr. Radhakrishnan Award from ESN Publications on 5th September 2020. She has guided many UG and PG candidates. Presently, 4 scholars are doing research under her guidance. She was life member in 4 professional societies and acting as reviewer for reputed journals. Her areas of interest are load frequency control, deregulated power system, power quality, power system dynamics, renewable energy systems, and microgrid. Thank you, ma'am. Your session, ma'am.
Thank you, ma'am, for giving a brief introduction about me. First of all, I have to thank Sai Ram Institute Management, HOD sir, and Muttamaran sir, and the co-coordinator Sasikala ma'am, for giving me an opportunity to give a lecture on this Atal-sponsored FDP. Shall I start the share screen, sir?
Yes, ma'am.
The screen is visible, sir?
Yeah, yes, ma'am. Visible.
Okay, once again, I thank the management of Sri Sai Ram Institute of Technology and Dr. Muttamaran sir for giving me an opportunity to give a lecture in this AICT sponsored Atal program. My topic is intelligent control in renewable energy systems and smart grid. So in this session, we will be seeing what are the renewable energy systems available in and around the world, and how that renewable energy systems are integrated in smart grid, and what is the need of a controller, how the intelligent control plays a role in the smart grid will be discussed in this session. Let us move on to the session. So the contents, as I have already told, we will be seeing about the renewable energy resources and what is a smart grid, what is the need for going for the smart grid, and controller for the renewable energy resources, what are the types of controllers, and based upon all this information, we have got a project, so that project will be explained, and finally the conclusion will be given. So first we shall move on to what is the need for the renewable energy resources. So the lack of electricity will be a main hurdle in the while we are going for in the rural areas of many countries. So renewable energy, particularly we will be mainly using solar, wind, bioenergy, geothermal, and tidal. Even though many resources are available, majorly we will be concentrating on solar and wind, which are more popular, and it is demanding to overcome the energy shortage, and also it will be reducing the air pollution, and it will be mitigating the greenhouse effects. So under such circumstances, we can locally place some small off-grid renewable energy systems as an resource, that is as an electricity provider for the rural areas, so that we can reduce the lack of electricity in those areas. So while in the overall in the world, we have that type of standalone renewable energy systems in many places. So the choice of renewable energy mainly depends upon what type of renewable energy resources which is sufficiently available throughout the year will be first noted down, and then next the overall cost of the system has to be noted down. So if you see, so as we are in 2020, if you move on to 2050, we will be transforming to net zero emission energy system. So far in the previous days, we have, in the olden days, we are mostly using the thermal power plant as a major source, and hydro power plant during the season time, we will be maximum utilizing the hydro power plant, which is only non-conventional, which is only the non-conventional or renewable resources, which is we have considered, which one we have considered the olden days. So if you go on, if you consider 2020, from 2020 to 2050, within these 30 years, we can see a drastic change in the entire electricity system. That is, we will be moving on to zero emission transmission system. That is, the entire system will be changed to a renewable system, where we can reduce the pollution, and where we can improve the quality of power. And so far we are using vertical integrated power system. So what is a vertical integrated power system is, for example, if you consider in Tamil Nadu Electricity Board, the Tamil Nadu Electricity Board is a solo proprietor of the power which we use in our home, industry, everywhere. So in this system, even though we are in India, in Tamil Nadu, we are generating the renewable energy, we are making power from renewable energy resources, we are consuming the power only from the Tamil Nadu Electricity Board. So this will be changed as the days are going on, and major research is taking place in this area, so that distribution companies and generation companies can be splitted down, and a consumer can buy a product from any other generating company. So those type of revolution will be taking place within these 30 years in India. So what is a renewable energy? So India, as I have already told, in India, as per the meeting report says, India will soon become the world's most popular country, adding the equivalence of a city, that is the size. So to meet the growth of the electricity demand, the next 20 years, India will need more power system to be operated. So renewable energy. So what are the components which you will be used, considering the natural resources, solar energy, biomass, and then geothermal, wind energy, tidal energy, wave, from the wave we can generate the power, and the hydroelectric energy, which is a golden power generating system, which we all know. So these are the renewable energy resources. But we will be majorly concentrating on solar, hydroelectric, and wind energy. So as per the statistics I have taken from the TADA website, so the power generation from 2000 to 2050, this indicates what are the resources we have used, and what are the installed capacity, and what is the share taken by the resources is shown in this statistics. So the power generation, so initially it is high. As the days are going on, in 2050, we will be seeing that solar is mainly improve is majority when compared to coal. So this coal will be getting on vanishing in 2050. So we will be majorly concentrating on renewable energy resources. So in hydro, this I have taken from the MNRE government. So that also shown here. So from the hydroelectric power plant, these are the major power plants which are available, and the number of potential capacity and the capacity of power being generated is shown here. So this is the statistics of hydroelectric power which is being generated. And with the help of solar power, we are expecting 450 gigawatt of power, renewable energy by 2030. With the majorly by solar, we will be generating 280 megawatt. So if we see, initially in 2010, the hydropower plant are playing a major role. As the days goes on, by 2020, initially at the time when the solar power plants came into role, the PV panel rates and all very high. So we are unable to purchase and go for a solar, that is for PV system. So as the science and technology is being improving, and the advancements in the fabrication, that is depending upon the fabrication, the cost of the solar PV cells also being reduced. So when compared to hydropower plant, the installation of PV is lesser, cost is lesser. So this shows the wind power plant places where the wind power plants are available all over India. So from these statistics, we can see what is the total capacity of each and every state that can generate the wind energy power. Wind energy, with the help of wind energy, the electricity is being generated from all these states. So totally we have this much of power from the wind energy. So if we see the statistics, in 2020, we are getting 35,500 megawatt of power when compared to 1919 it is 32, but it has been reached up to 35,500, a huge, a drastic improvement of power increase in the because of wind energy. So solar and wind are playing a vital role in the renewable resources, mainly in the power sector. The next renewable energy which we can consider is bioenergy. So in this bioenergy is, as a diagram, from the diagram we can see what are the resources for this biomass resources, agriculture crop, and then forest residues, and then industry residues, animal residues, municipal solid waste, sewage waste, everything can be considered as a input to the biomass resources. With that, we can generate a power of, we can generate a power of around 25,000 megawatt, and the installed capacity is 5,941 megawatt. So with the help of bioenergy, we can produce. So with this basic information, the India's as of 2022 survey, we have 5 gigawatt of small hydropower plants and 10 gigawatt of biomass energy, and with the help of rooftop solar itself, we are getting 40 gigawatt power, and with the wind we are getting 60 gigawatt power, and with the help of photovoltaic we are getting 60 gigawatt power. So this renewable energy is going on improving, that is making more innovations and more power available to the country. Thereby we are reducing the lack of electricity problem. So as shown in the graph previous slide, the overall share of energy from the renewable resources is shown here. So the down arrow indicates 2019, and in upper it indicates the 2020 targets, and the overall renewable energy capacity, installed capacity in India is shown in this chart. So this is a present scenario in India. So the renewable energy target in 2022 is, as I already shown in the previous slide, it is 175 gigawatt. So that is shown here. That is put together solar rooftop and solar PV with the power percentage is 57%, wind is 34%, and the remaining a smaller amount is being shared by the biomass and the small hydropower systems. So the project, this is the renewable energy systems installed capacity in 21-22. That's in that particular year. These are the places where we have installed the renewable energy resources. So in Tamil Nadu, 12% of systems are being installed. Maharashtra 13%. Similarly, Madhya Pradesh 7%. So all these things are put in the bar chart. All these data are available in MNRE sites. So with this basic information about the smart grid, renewable energy resources, we shall move on to the smart grid. The power grid, so far we are in olden days, we are using the renewable energy, power grid. The power grid, that is, the power grid consists of some thermal power plant, nuclear power plant, and a diesel power plant. Some amount of energy during the seasonal time will be getting from the hydroelectric power plant. So these powers are fed to the grid. Even though if we are feeding it, that power to the grid, we face so many complications. With these complications, the power sector, the grid is capable of supplying uninterrupted power to the consumer. So by considering that three factors, that is, the quality of power is maintained, and then security is maintained, stability of the system is also there, and the reliability of the power is also being available. So all these things are to be adopted in smart grid also. So as a smart grid is a concept of being contemplated by several countries, that is since more than a decade ago. Each and every country, including India, is at different level of implementation of this smart grid. So the rise of renewable energy resources have changed the landscape of energy production as well as the consumption. So the consumers are given a chance to become prosumers in project. That is, in the power grid and all, we are the consumers who are buying the power. But in smart grid, we make the consumers as a prosumer. That is, they can also produce power. That is called as prosumers. So the consumers are given a chance to become prosumers in projects. Like in our home, we can put a rooftop power plant. So by that, we can make the power generation and distribute and transmit the power, thereby pushing a need of bidirectional input. That is, at the time of lacking the power, we can get the power from the grid. If we are having plenty of power in that is with the help of solar power plant, if we are generating plenty of power, means we can transfer the power. That is a bidirectional input. So power discoms have long suffered because of energy loss and theft in the transmission in the previous days. So the several states have stated that replacing the traditional meter, that is in our house and all, we will be using the energy meters. Previously it is analog meter, now it has been transferred into digital meter, and that meters also will be changed as smart meters if we have the rooftop solar panels in the home. So the traditional meters will be converted into smart meters, and that have been implemented and witnessed as a positive change in the revenue realization. That thereby we are generating revenue to the consumers. So the complex grids distribution system make it difficult to bring all these utilities in the same platform and implement a smart grid in a smooth manner is a toughest task. So it is very, very difficult, and slowly it is being implemented. So the complex, that is slowly it will be implemented. The smart grid mission has been taken, initiative has been taken by the government with a high importance on R&D, that is research and development, and phase-wise implementation of smart grid has been taking place. However, it will be achieved in the field of electricity within the forthcoming years. Okay. So the Tamil Nadu is very, very, in this concern, the Tamil Nadu is very, very far ahead when compared to other states. That is, it appears top 10 producer of renewable energy resources all over the world. It is given by the Asian Market Energy List. Okay. So with this basic information, we shall move on to smart grid. What is smart grid? It is an electricity network which will be enabling two-way of flow of electricity. As I have already told, if a consumer is having a rooftop, so rooftop PV panel are there, they can use the power for their own and they can sell the power to the government. If they are having lack of power means it will be given to the, that is a power from the government can be taken by the consumer. So it is a two-way flow of electricity as well as data with a digital communication. 1 second. With the digital communication technologies, whereby we are detecting and reacting and proacting to the changes that takes place while we are using the system, and we can solve the issues, multiple issues. So that is in power grid and all, if a fault occurs means we have to cut the system, that is we have to a particular area as being detected, that is what to say, it will be that faulted part alone will be isolated from the healthy area, and that faulty portion will be rectified and connected to the grid. Whereas in small grid, they have the self-healing capability and enables the electricity consumers to be an active participant in the system. So in order to know more about smart grid, a small video presentation I will show you.
Our current electric grid was conceived more than 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener. The smart grid enables newer technologies to be integrated, such as wind and solar energy production and plug-in electric vehicle charging. With our participation as informed consumers, the smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with us to help manage our electricity needs. The smart home communicates with the grid and enables consumers to manage their electricity usage. By measuring a home's electricity consumption more frequently through a smart meter, utilities can provide their customer with much better information to manage their electricity bills. Inside the smart home, a home area network, or HON, connects smart appliances, thermostats, and other electric devices to an energy management system. Smart appliances and devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills. These smart devices can be controlled and scheduled over the web or even a TV. Renewable resources, such as wind and solar, are a sustainable and growing source for electric power. However, renewable power sources are variable by nature and add complexity to normal grid operations. The smart grid provides the data and automation needed to enable solar panels and wind farms to put energy onto the grid and optimize its use. To keep up with constantly changing energy demands, utilities must turn power plants on and off depending on the amount of power needed at certain times of the day. The cost to deliver power depends on the time of day it is used. Electricity is more costly to deliver at peak times.
Whether the audio is hearable, sir? Sir, audible, sir?
Yes, ma'am.
Okay, sir.
Because additional, often less efficient power plants must be run to meet the higher demand. The smart grid will enable utilities to manage and moderate electricity usage with the cooperation of their customers, especially during peak demand times. As a result, utilities will be able to reduce their operating costs. By deferring electricity usage away from peak hours and having appliances and devices run at other times, electricity production is more evenly distributed throughout the day. The power being used right now was generated less than a second ago, many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity production, reducing the need to fire up costly secondary power plants. The distribution system routes power from the utility to residential and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any break in this system caused by storms, bad weather, or sudden changes in electricity demand can lead to outages. The smart grid's distribution intelligence counters these energy fluctuations and outages by automatically identifying problems, then rerouting and restoring power delivery. Utilities can further use distribution intelligence to predict and manage electricity usage with the cooperation of their customers, leading to lower production costs. The charging of a plug-in electric vehicle can be managed over a home area network, or HAN. The HAN can balance the demand for electricity across the household and prioritize between the electric vehicle and other appliances to manage electricity usage and reduce costs. With smart grid technologies and consumer participation, utilities can more easily handle the increased demand for power to run the electric vehicles and ensure charging needs are met. By adding more plug-in electric vehicles to the grid, we have the potential to reduce fuel costs, lower our dependency on foreign oil, and help reduce greenhouse gas emissions.
Okay, so in the video, what we have discussed has been visually shown. That is, the consumer can act as a prosumer, that is, they can generate the power and they can consume the power. So from the video itself, we can see the smart grid, even though it is very, very flexible, we have so many complications. So that are to be taken as a challenge by the R&D department, and we have to improve the system. So what is our need? Why we go for smart grid? So the largest still now, but the power which we are using is called as a unidirectional. That is, the power generated, transmitted, and consumed in a one way. That is, we pay the money and we get the electricity. That is called as unidirectional power transmission. So the net carbon emission of is now it is 74% of electricity is being going on towards the renewable energy resources. As I have already told, by 2050 we will be having zero carbon emission scenario. So as we move on to renewable energy resources, we are in a position to penetrate towards the decentralized. That is, we are decentralizing is a thing, but we are converting the generation into different generation companies. That is, a consumer who is having a rooftop PV system is a generating company. They can generate power for their own and they can sell the power to the government. So they are also a generating company. Similarly, many generating company can compete in the power bidding, energy bidding sales, like in the share market. Here the power sharing is also will be taking place. So the renewable energy generation will be a challenging one. So 74% of the world electricity will be transferred by renewable systems. So once we go for transformation towards the renewable system, decentralization of the power system takes place. So the grid has a capability to enable, that is, the demand response strategies to integrate and maximize the use of intermittent generation and battery storage, while minimizing the electric waste. With the help of this intermittent generation, that is nowadays, as of now, what the Tamil Nadu electricity government is doing is they are taking the renewable, now in major places, the renewable energy resources are being implemented. They are using that power as a supplementary, that is intermediate generation, and using it to the, connecting it to the grid. While with that, they are minimizing the electricity waste and energy cost, and thereby they are ensuring the reliability. As the power is being transmitted at all the time, 24 hours, it will be reliable to the consumers. So the renewable energy resources are intermittent and variable. So as we say, renewable energy resources, we consider, for example, solar means all the 24 hours we cannot generate power from the solar. Similarly, wind, that is a PV, as the sun radiation is higher, we can get large amount of power. If the sun radiation is not there, means the power consumed, that is power consumed by the PV will be lesser. Similarly, the wind, when you go for the wind power plant, the air circulation should be, the wind should be there for the working of a wind turbine power plant. Okay, so it is considered as a intermittent source and it is a variable source. So we are going to integrate this system with the present existing power system. So thereby the complication arises that the system stability has to be maintained, electric power balance has to be maintained, and reactive power compensation has to be done. So once if you go for a integration with the integration of this renewable energy system with the power grid, we have to keep into consideration all these factors. The system stability and the voltage is to be maintained as a constant, and frequency has to be maintained as a constant. And these are the major things to maintain the power quality of the system, and the power should be always reliable to the consumer. So all these points are to be considered when we are going to connect the renewable resources with the grid. So the consumers will become active players when we when we sell the power. That is, we can track and shift our consumption to hours of a day when the electricity becomes cheaper, and in those places we will be in the that is those who are selling that electric supply to the grid will be having a smart meter instead of the traditional energy meter. Okay, with this information we shall move on to what is a conventional grid, power grid, and what is a smart grid. So in the conventional grid, the manual restoration is there, but here the self-restoration capability is there. So designed as a the entire system is centralized generation. So it is a one-man show. That is, it is a monopoly system. Whereas smart grid is a integrated distributed generation. That is, we have n number of generating systems, and the generating systems can deal with the consumers directly. It is a manual monitoring, real-time data is not available. Whereas if you go for a smart grid, self-monitoring, and it is a real-time data, it consists of real-time data and sensors are also available. It is a one-way communication, but this is a bi-directional communication. If there is any power quality issues, if the breakdown occurs, means it is very slow in response, and it is as it is having automatic components, so it is faster in solving the issues. So focuses on outages, and here the power quality is maintained as a considered as a priority 1. Response to system disturbances such as damage and all. Here it automatically detects disturbances and minimizes that effect towards the consumers. So the it consists of analog components. Here it consists of digital components. So which is shown in the pictorial form like this. In the olden days, you will be having this type of thermal power plants. Here we will be using the renewable energy resources, and then that has been centralized and transmitting the power towards the consumer. So from the diagram itself, we can say it is a one-way system, whereas here we can see it is a bidirectional. See, the rooftop consumer can sell the power, and they can get the power if they need, and from the battery, so they can use the batteries also to store the energy. So this smart grid is a bidirectional one, and this is a unidirectional system. And this is also another way of representing the smart grid versus traditional grid. Okay. So far we have seen what is a smart grid. Now we shall move on to we have seen what is a smart grid, and now what are the components in the smart grid will be discussed. So the mainly it consists of distributed energy systems. Distributed energy systems, we will be having distributed generation, and the transmission distribution grid management will be taking place by a component called as independent system operator. So independent system operator, it maintains security, stability, and voltage maintenance, frequency maintenance. Everything will be taken care of by this component, and it is consisting of 12 ancillary services as suggested by the NERC. It consists of 12 ancillary services. The 12 ancillary services will be taking care of the system stability and the security and reliability of the system. Then it mainly focuses next on the increases the consumer choices. That is, we can, as a consumer, I can purchase a power, those who are selling at a minimum rate and which is optimal to me and reliable to me, that power I can purchase. It is not a strict order that I should buy from some X. I can buy from any one generating company which I can, which I am willing to purchase. So dynamic pricing, there is a pricing. So still now the power, we all know in the electricity bill, we will be the rate, the per unit is being fixed. Whereas if we go for smart grid, the pricing will be dynamic in nature. And we are focusing on advanced software and hardware components. So that is the energy dashboard, controller, the sensors, smart applications, smart meters. So everything will be advanced in technology. So next we go for communication systems. So this communication system also plays a vital role in smart grid. So smart meters for data transmission, that is for data generation and energy consumption in control areas at the utility. So the power line communication or wireless mesh networking will be used to transmit the data towards a control center. So as I have already told, these are the components. So we will be having renewable energy resources. So with the help of renewable energy resources, the person can generate a power, so that can be given to the grid. So with the help of the smart meter, we can check what is the amount of unit we are given to the grid, can be checked with the help of the transmission smart meter. And transmission is automatic, distribution is also automatic. Demand response management will be done by the smart grid. Smart grid, that is smarter applications, as we have seen in the video. In the washing machine, we cannot for an example, it is shown in a washing machine, we can use for a particular time the power, and power saving can be done. So electric vehicles are going to be slowly increasing, thereby the use of the fossil fuel, the petrol, diesel can be reduced, and the energy storage can be done. So with this basic information about the smart grid, we can say what are the advantages of using this smart grid. We are optimizing the integration, we are increasing the reliability of supply, quality of supply, and stability of the supply with the help of the component called as independent system operator, ISO, and we are reducing the peak demand. As we are having n number of generating companies, we can reduce the peak demand and resilient to the disruption and reduce the grid restoration time. That is, if there is any fault, the grid restoration time can be done as soon as possible when compared to the traditional grid. So it optimizes the demand and supplies the power at the local and distribution level, thereby the transmission of power, that is transmission losses in the power can be reduced. Okay, I have already told distributed energy resources, DER. So what are the modes of operation of DER? We have 3 modes of operation: standalone mode, battery charging mode, and grid connected mode. Let us see one by one in. Before going in about that these 3 types, we shall see what is microgrid and smart grid. What is microgrid is all these things. This is standalone system which we are using for rural areas alone, it can be called as a microgrid. For a small all these smaller units put together, we call it as a smart grid with some digital communication. So n number of microgrids will be considered as a smart grid. So from the visual, we can see that microgrid will be enabling the continuous operation while we are disconnecting from the main grid. That is, the first introduction point itself, I have told so many rural areas are not even having power supply. So in those places, we can use these microgrids and generate power to those islands. That n number of microgrids can be connected together, forms a smart grid. So the smart grid enhances the availability, reliability, and flexibility. So that is the microgrid is a small scale power supply, whereas smart grid is a large scale power supply. So it can provide bigger community. And if you go for a microgrid, it will be supplying power to the local loads. And this n number of microgrids are connected, so it can supply power even to the outstation, that is outside the local area. They can also give the power. So yes, the microgrid size will be very smaller, and the smart grid will be larger. And then small substations can be called as an individual microgrid. Okay, and here we can say it as distribution of total generation economically will be connected through a component called as load dispatch center. And if you go for a microgrid, it is smaller in size, so the decision making implementation will be taking place faster when compared to smart grid. So if you go for a smart grid, it is national grid level component. So it will be involving majority of long transmission and distribution lines. And then majorly the microgrid consists of we say the smart grid is a microgrid is a subset of smart grid. N number of microgrids are called as smart grid. Once again, I'm repeat. Microgrid is a subset of smart grid. From the diagram itself, you can say microgrid is a subset of smart grid, and smart grid is a combination of n number of microgrids. So the microgrid can be considered as a distributed energy system, that is DER. Whereas smart grid will be it's a combination of this microgrid, intelligent controllers, data communication, everything put together is called as a smart grid. So in a microgrid, we can get the power depending upon the location. Sorry, if wind power is more, means that we can use a standalone wind power system and we can generate power to that area. If it is having irrigation, that is solar irradiance higher, means we can go for PV system. So this is a major difference between the smart grid and the microgrid. With this basic information about the system, we shall move on to what is standalone system, battery charging mode, and the grid connected mode. Sir, 1 second, sir. Okay, from the diagram itself, we can say standalone mode. Standalone mode is, see from this diagram, we can see as the wind turbine rotates, the wind energy will be generated. The generated power is given to the electricity generated will be given to the home, and also it is stored in the battery if it is not utilized by the home. Similarly, the solar panel with here, with the help of the wind in the wind power generation, it can be converted. It cannot be converted. It will we want to be converted. It is a AC power, so we can directly use it to a home, and it has to be converted with the help of a AC/DC converter for for charging the battery. Whereas if you go for a solar panel, the output of the solar panel is a DC output. So with the help of the charger controller, we can convert, we can store it in the battery, or we can directly give it to the inverter, and from the inverter we can give it to a home appliances. So this is a standalone mode which we will be using in the rural areas. So in the previous one, if we are going for a charging mode, means battery charging mode. So the solar power with the help of the PV module, the power generated is DC, that will be stored by, see, this charge controller is used to what to say, this is variable in nature. The power generated by the photovoltaic system is variable in nature. So that variable power is being converted into a constant DC output with the help of the charge controller, and that output from the charge controller is taken to the battery to store it for the next one is a grid connected system. So grid connected system, so we have a hydropower plant, solar power plant, and a wind turbine. So all these things put together is given to a actually here we have not shown the charge controller. So charge converter will be used in the solar panel, and then the regulated output is given to the inverter. So that inverter will convert that into AC, and it will be used for the home appliances. So this is a grid connected system. So if you go, what is a hybrid power means? Only one source is used, means we can say it as solar PV system or wind system. If hybriding is, we are going to use one or two or more resources to generate a power, is called as a hybrid power system. So we can have n number of resources like PV wind and fuel cell, PV wind and battery can be used. So here in this visual we can see solar and PV wind system to generate a power to the home appliances, and also it is given to the grid. This one is photovoltaic system and a fuel cell. These are the examples of hybrid power system. Hybrid PV system and fuel cell system topology is shown here. So here you will be using the fuel cell for generating that is for discharging the DC output. So here, if you go on towards the renewable energy resources, usage of power electronics devices comes into role. So usage of power electronics devices comes into role. So once if the more number of power electronics devices are being used, means then there raises the power quality issues. That is, the quality of the power will be affected. So these are the challenges while we are connecting the renewable energy resources towards the grid. That is, the grid stability will be affected. That is, it has to be maintained. So these are the complications which you have to meet, and with the help of the advanced technology, we have to overcome all these complications and provide power to the consumers with the help of the renewable energy resources. So some of them are grid stability, and then reliability, voltage regulation, power quality, and then power factor improvement, mainly the energy management system, and we have to optimize the maximum power generation. As we are going for PV system and all, energy storage devices plays a vital role, and because of all these things, the harmonics comes into picture. So these harmonics has to be reduced. That is, we have to minimize the losses, and we have to use less loss power electronics devices with the help of the technology development, and by integrating the renewable energy resources, all these things are to be taken into consideration. So if you go for a smart grid, this comes into role. That is renewable energy integration, communication in smart grid, cyber security, and finally the consumer support. So first, grids, as I have told, grid stability has to be improved by integrating the renewable energy system with the grid. So we have to maintain the production as well as that is, we all know whenever we deal with the power system, we will be mainly saying that there should be a balance between the power generated and the demand. So that has to be maintained even if it is a smart grid or a power normal traditional grid. So this concept has to be maintained. Next, renewable reliability of resources. So these I have some videos for this all this reliability about the smart grid. So these things I will show in the end of the session. Voltage regulation. So with the help of the voltage regulators, we can synchronize the renewable energy system with the power grid. So power quality. Power quality is the defined sine wave of the voltage is being affected, means this is called as issues in power quality. So how the issues in power quality occurs? So these are the some issues: flickering, unbalance, sag, swell, transient, and then interruption, frequency deviation, under and over voltage. And so all these will be because of the power electronics, the usage of power electronics devices, majority usage of power electronics devices, and all this has to be reduced by making advances in the, by making improvement in the usage of power electronics devices. Okay. So if you are not maintaining, means the load, the equipment which are connected to the system will be getting affected, and the efficiency of the system, that is the component will be reduced, more amount of power will be consumed from the grid. So for that only, we are using a compensating device that is called as SATCOM. For example, I have shown the SATCOM. We are having n number of voltage compensation devices, that is FACS devices, UPFC, IPFC, so UPQC. So many FACS devices are there. They can compensate for both for frequency as well as the voltage. So that is shown here. Next, power factor improvement. So we already know the power factor should not be lesser than 0.8. It should be maintained at 0.8, not below that value. So we, in companies and in industries and all, we will be using the power factor meter itself to make the, to penalize the consumers. Okay, so the power factor correction, if it is not considered, means what will happen is current harmonics will be taking place. So in order to reduce that current harmonics, we will be using the filters. So it may be a capacitor, or it may be a FACS device. So any appliances, by use of that, the power factor has to be improved. So if you see this diagram, power supply from the transformer, it is given to the load. So in the load, the power factor is being reduced. So this is a wrong thing. So with the help of the power factor correction, we are maintaining the power factor. Next, we shall move on to energy management system. So what is energy management system? As a name itself implies, we have to manage this all the generating companies and the distribution companies with the system. That is without affecting the quality of the power system, and the cost also should be of minimum value. Everything has to be maintained. That is called as energy management system. So this energy management system, we consider it in a cycle. That is, first we will be planning the system. What is to be done has to be planned, and then it should be implemented, and it should be verified. After implementation, we have to verify it. How we will be verifying it? By repeated monitoring, and then the company commitment towards the work, and then understanding how the energy be used. So this cycle, it should be repeated in order to maintain the good energy management. So the demand estimation is the power from the resources, and then what is the minimum operating cost? Everything has to be dealt. That is being done by the energy management system. As I have told in the previous slides, in the smart grid visual, I have told about independent system operator. So that independent system operator is also called as energy management system. So it will be taking care of all the parameters of the system to maintain a good quality and reliable power to the consumer. Optimization, as we already know, optimization, as the name itself implies, we all in general make minimum usage of fuel to get a maximum profit. So with the help of the renewable energy resources, as it is plenty of available in nature and it is zero carbon emission, we can optimize the entire system. And some of the energy storage devices I have shown. Harmonics we have dealt, that is with the help of the converters, mainly because of the semiconductor elements, the harmonics have been introduced, and those things are to be reduced with the help of the filters. So minimization of power distribution, that is, this is a centralized power with the help of the coal. Second, sir. Shall I share the screen, sir?
Yes, ma'am.
So in small grid, so far we have seen what is a smart grid and what are the parameters in the smart grid. So one of the parameter is we have to minimize the power distribution. So if we go for centralized power means the power will be generated in a some long distance. So with the help of the long transmission network, we will be transmitting the power. So for that we will be needing of high rating cables, lengthy cables like that. So if we go for a renewable energy systems and in the smart grid, that distribution will be, that losses will be reduced. That is, we are connecting the distributed energy resources to the consumer, nearer to the consumer rate, and integrating the IoT. So thereby we are reducing the losses and we are updating the infrastructures. This is a conventional power plant which we have shown here, and this is a smart. So as the renewable energy systems are introduced, the role of power electronics devices also being increased. So everywhere in a converter we need a power electronics device, and in solar power, in PV system we need a semiconductor device, and from the converter and then from a battery to a charge controller we need a power electronics device. Finally, if you go for a inverter, there also we need a semiconductor device. So okay, so what is the need of a controller, and these things we will be dealing in controller side. So the technology, so in smart grid, the technology plays a vital role. It's communication between each and every component in the smart grid plays a important role. So thereby we are making the system to be highly reliable and capacity of taking the action of its own. By the help of advanced control methods we can go for. Sir, இது ரிலேட்டடா இருக்க வீடியோஸ் இப்பவே போட்டு காட்டுவா இல்ல கொஞ்சம் லாஸ்டா போடலாமா சார்? சார்
your wish.
இல்ல அப்புறம் உங்களுக்கு டைம் ஆயிட போகுது, அதுக்காக கேட்டுக்கிறேன். One second, sorry. Just we shall see this video and move on.
That due to at Veritone,
We believe artificial intelligence will play a key role in building a safer, more vibrant, transparent, and empowered society. Green energy is poised to change our world for the better. But to set off a green energy boom, the grid must go digital. Grid operations are becoming more complex. Today's utilities must respond to changing weather and energy demands, and day-ahead forecasts are no longer enough. An ever-growing number of distributed energy resources has led to network congestion, inconsistent energy delivery, device failures, and blackouts. Providers are under pressure to deliver a consistent and profitable energy supply across a variety of old and new energy sources, which often collide. Managing these complexities can be daunting. That's where artificial intelligence comes in. Veritone Energy Solutions are harnessing the power of AI, revolutionizing today's energy grids and cutting millions of dollars in costs for utility companies and consumers. Utility grid operators, equipment and storage providers, and energy aggregators use Veritone to optimize their smart grids. Our patented AI technology first collects current weather forecast data, energy demand, and pricing data, and sends this data to the control hub. Autonomous control and decision-making can be centralized or distributed to individual microgrids and devices. The control hub also detects the current state and capacity of each energy device on the grid. From there, we apply predictive models, rules, and learning to determine the ideal energy supply mix and pricing to meet grid demand in near real time. So forward-thinking operators know how much energy to send to which device, at what price, and when, based on predicted future conditions. This process repeats every second of every day for a perfectly synchronized and optimized energy grid. With Veritone, utilities can deliver profitable renewable energy with unparalleled grid stability and efficiency. We're optimizing the energy grid and accelerating the world's transition to more sustainable, reliable, and affordable energy. Join the AI revolution. Contact Veritone today.
Okay, so with the help of the video, rather than my explanation, you will be much clear about the technology development and cyber security also shown in the video itself. So by transferring the data from one to one, the security of the system, security of data is also maintained as a confidential. That is, the security of the data is may be maintained in the cyber security system with the energy. So thereby we are reducing the theft, abuse, and malicious activities in the smart grid is concerned. So the challenges of ensuring the cyber security in a smart grid is it is diverse in nature due to the diversity of the components and the context where we are applying the smart grid. So renewable energy integration. So so far we have seen what is renewable energy, and it will be fluctuating in nature. So we are going to integrate with the existing grid. So when we are integrating it with the existing grid, we have to provide protection against all the parameters. So in a smart grid, the next thing which we are going is communication. So communication between each component of the smart grid is very, very important in order to maximize the available power in a reliable and cost-effective way. So therefore, we have to efficiently manage the power system with a new intelligent control system in the smart grid. So in a smart grid, the controller plays a vital role. So the consumers, sir, sir, shall I proceed? Hello? Sir, am I audible? Some sound came.
Yes, ma'am. Yes, ma'am. It is okay.
Okay. So if you go for next point is consumer support. As we all know, in every sector, the consumers are major concern which we have to consider. So the lack of consumer awareness about the issues in the power sector can be reduced, and the consumer support is must for implementation of smart grid. In order to, why we are making it as a consumer support is a major issue means the consumer is acting as a prosumer. So they should know each and everything that happens in the smart grid. So thereby we are reducing the peak load consumption and we are promoting the distributed energy systems. So, but the consumer should be aware of new technologies and they have to support the utilities by and also understand the benefits about the smart grid in order to get benefited by own and also for the nation. So this is a pictorial representation of your this is our present electrical structure. This is our smart grid structure. So here only one-way communication, here two-way communication. So far we have seen all these things that has been summarized here. And because of going for this renewable, what are the things we will be considering is thereby we are improving the electrical power generation and distribution system. That is, we are integrating electrical infrastructure and also the ICT infrastructure. And it is more efficient and better management of power. And by use of the by going to the renewable, by going to the smart grid, we are increasing the use of renewable energy resources. Thereby, we are reducing the pollution in the environment. And then by using smart meters and demand response systems, we are providing a better management of energy usage. So those things are the advantages. And if you see, this is the structure of a smart grid. Here, I have already told this operator is called as a ISO independent system operator. So they will be dealing with the bulk generator. They will be dealing with the consumers, the bulk power generators, transmitters and distributors. And also they will be maintaining the security information about the consumers as well as the generators. So those things are highlighted here one by one. So if you see the consumers, they can use smart meters and real-time usage data. That is, they can see how much of power being generated and utilized from the grid. And they can use the smart appliances for the minimization of your energy being generated. Similarly, in transmission, we can use high use of variable energy resources. Thereby, transmission losses can be reduced. And in distribution, we'll be using the bi-directional metering and distributed storage. So here you will be using the fuel cells, battery, thereby reducing the cost and overall management is done by the service provider. And this we have already seen in the first session itself. What are the applications of smart grid? That is, we are integrating, that is renewable energy comes into role. We are integrating it and distributed generation takes place and electric vehicle integration. That is, with the help of electric vehicle, we can reduce the usage of fossil fuels, and with the electric vehicle, we can generate power. By the rooftop electric vehicle, we can generate power and supply it to the grid. So because of that, flexible generation will be there. Cyber security of the system is maintained. Energy storage devices are used and demand response is good in smart grid. Dynamic reactive power, that is reactive power and the active power are dynamic in nature. So that has to be maintained as a constant one. Wireless communication is there. So thereby the communication will be taking place in faster way. That is the entire distribution system is automatic in nature, and with the help of smart meters, bidirectional energy flow will be taking place, and each and everything, all these are the accessories of the smart grid. So in the previous picture I have shown that just in the form of a flow diagram, but here we have seen the it in a different way. That's all. So in distributed generation, let us move on to mainly by two resources. So far we have seen renewable 3 resources, but majorly in India and in Tamil Nadu, we are mainly concentrating on solar and wind. So this YouTube I will share you can see it later. So this PV system is the latest floating PV model which has been installed in Thoothukudi. Our Chief Minister M.K. Stalin has inaugurated. It is around 150.4 crores. It's a floating PV plant which is being done by the Southern Petrochemical Industries Corporation Limited at Thoothukudi. So this major installation capacity. The largest producer of wind in India is again the credit goes to our Tamil Nadu. So in Tamil Nadu only, according to the press meet, it is seen that Tamil Nadu has the highest installed wind power capacity of 9,867 megawatt as on June 2022. So which is the highest among all the states. So we have the credit, the Tamil Nadu has a credit of is installing very high, huge wind power capacity. So which is being written in the Ministry of Renewable Energy in Parliament. So this is which we have taken the information from TADA, our government website. These are the renewable energy resources which we are being used and the power sector information. With this basic information about the system, let us move on to the controller. So controller plays a vital role in smart grid wherever we go. That is in renewable energy resources we use means we are using solar and wind. In both the places we need a power point. We are placing a maximum power point tracking. So what is that maximum power point tracking? As per the maximum power transfer theorem, the theorem is that is whenever the source resistance is matched with the load resistance, the maximum amount of power will be transferred from the source to the load. This is the maximum power transfer theorem. So this theorem, we apply it to the wind as well as the solar. For example, if you consider solar, in solar, the power, that is depending upon the irradiance level, the voltage and current may vary. So the voltage depends upon the temperature of the panel, depending upon the irradiance, that is radiation from the sunlight, the current depends, and the temperature, the voltage depends. So the generated current and voltage will not be constant one. So it is instantaneous in nature. It depends upon the environment. So I and V, that is the voltage and current of the system varies. So what happens? The resistance of the system also will be changing. So whereas if you go for a resistive load as a load means the load is fixed. So depending upon the by using some algorithm or by controller, we are tracking the maximum power from the system towards the load. So that is the maximum power point tracking. So for that we are having n number of algorithms and controllers. We shall see a glance of few. So due to nonlinear, that is which I have explained you, due to nonlinear characteristics of power, voltage of power versus voltage of the PV system, it can deliver maximum power at a particular point of operation. That is at the point where the load resistance is equal to the system resistance. So that point is called as maximum power point tracking. So, so far in previous days, we have considered the PI controller as a for our research work, and with that PI controller we worked. So before the usage of PI controller, initially there won't be any disturbances. So feedback, that is where all the system are under open loop condition. Once the closed loop condition comes into existence, we go for PI, PID controllers. And those among those controllers, PI is considered to be best. As I have done my research in PI, when compared to PI, PID, and integral, PI is effective. It is simple and effective. As the science and technology is improving, we are moving on to model predictive control systems or linear optimization systems. And as times goes on, in real time, now we are using the deep reinforcement learning, machine learning, and artificial intelligence, like that. So many algorithms are coming into role. So that has been shown in this diagram. Initially it is open loop, feedback control, optimal control, and then now stochastic controls are there. We shall see this stochastic control in detail. And then adaptive control also came into role, self-learning control. Finally, the intelligent level of controls came into picture. Okay, so initially, when the conventional control was came into role in 1960s, it is mainly, as I have already told, P integral control and PI control or PID control. There, the plant and the system, that is plant and the control will be there. As the intelligent control comes into role, there we will be using the AI, an artificial neural network, and fuzzy logic. So there will be using the expert system knowledge level, like that we will be dealing. And then finally, at the fourth level of advancement, we go for intelligent control. That is intelligent control is ability to evaluate the human capabilities, such as planning, learning, and adoption, and adapt according to the system. And another, there is, let us see. So among them, I have taken some optimization algorithms that we can classify into traditional algorithm and heuristic algorithms. So in traditional algorithms, in heuristic algorithms, we have 3 classifications again: evolutionary, natural-based algorithms, and logical search algorithms. So in evolutionary, for some example, I have shown here genetic algorithm, particle swarm optimization, and differential evolution. And if you go for natural-based algorithms, so these are some algorithms. And for my research work, I have considered particle swarm optimization and differential evolution. And from here, I have taken the flower pollination algorithm and done the research. So first we shall go for the nature-inspired algorithms. So when we go for an algorithm, we have to first fix the objective function. The objective function is what are the parameters to be tuned. For my research area, we have taken the frequency has to be maintained as constant. In the grid, that is in the smart grid or in a power grid, we have to maintain the frequency as a constant value. So for that purpose, we have to first fix the objective function. So in order to fix the objective function, we have 4 types of objective functions. Fitness function, that is minimization of integral square error, minimization of integral absolute error, integral product of between the squared time and absolute error, and integral absolute error multiplied by the time, that is ISE, IAE, ISTAE, and ITAE. Among these, I have chosen integral square error. When compared to all these, it is simpler and easy to use, and computation time is also less when compared to all these fitness functions. So first we have to fix the objective function, and then this, based upon this objective function, the algorithm is used to tune the parameters of PI. The major component control which we are using in all the system is PI or PID or integral controller. So that has to be tuned with any algorithms. So first we shall see what is flower pollination algorithm. So flower pollination algorithm is again a natural inspired algorithm. The main objective of this algorithm is to produce a optimal reproduction of plants in order to survey to the maximum most fittest flowers in the flowering plants. So the characteristic is it will be pollination will be taking place between them by flowering places or by other pollen agents. So based upon this pollen transfer, we can classify it into 2 types: biotic or cross-pollination, abiotic or self-pollination. That is, if the pollination takes place within the flower, then it is called as self-pollination. If the pollination takes place between 2 different flowers, then it is called as cross-pollination. So this may be because of bees or by any flies or because of wind. It may be any other agent. So by considering these points, these characteristics of the pollen flowers, we have designed an algorithm. So the pollination recipe, as I already told, it's a transfer of pollen from one space to another. The transfer of pollination will be taking place by local or global pollination. Among the total pollination, in general, 90% will be the cross-pollination. Only 10% will be based on the local pollination. So this switching between local and global will be decided by the switching probability rho. So based on this, the flower pollination algorithm has 4 rules. One is, first we have to consider the cross-pollination as a process of global pollination. And the pollen carrying agents will be called as Levy flight agent. And then for local pollination, the self-pollination will be used. So the pollinators such as insect can develop a flower constancy which is equivalent to reproduction probability, that is again proportional to the similarity of two flowers involved. So the interaction between the local pollination and the global pollination will be done by the component called as rho. So the process is like the, sorry. Okay, forgotten. Okay, so based upon these 4 points, we will be designing the objective function, and then we will be tuning the PI controller and get the final optimized result with the help of the flower pollination rule. And the next rule is a one slide has missed. Sorry, 1 second. Next one is actually differential evolution algorithm. It is again a stochastic algorithm. In this algorithm, we will be having 4 components, that is initialization, mutation, crossover, and selection. Initialization is we are initializing the number of parameters and what are the control variables we will be using. Those things will be initialized, and the mutation process takes place once. And that is we are initializing the process, and then we are finding the fitness function. That is fitness function is depending upon the individual value, we will be fixing the initial fitness function. And then next initialization is over. Next we go for mutation. The mutation is done, and we will be getting a vector called as trial vector. So the trial vector will be evaluated, and that will be compared with the current individual. If it is greater, means it will be going on to the next position. If not, means that the trial vector will be discarded, and then we will be replacing the trial vector, and the process will be repeating. Once the maximum value is attained, the process gets closed. That is called as selection process. Up to that, the process will be repeating. The last one is the particle swarm optimization method. It is based upon the behavior of the birds and the fishes. Mainly like flower pollination, we will be having here G-based and P-based. If here we will be using the distance and the velocity of the, that is distance between two birds, flying birds, or next one is a velocity of movement, how fast they are moving. So those 2 points are considered, and based upon that, we will be calculating the P-based value and the G-based value. And so these 2 equations will be using and finding out the maximum optimal solution. So these 3 algorithms I have used to find the maximum, to get the results for my work. So these can be implemented in either in the MPPT tracking as well as in the charge controller controller, and in the inverter side also. These algorithms can be implemented. So next 5 to 10 minutes, I will show about the marine project which we have got from the AICT. In our college, we have got fund around 16 lakhs from AICT for this RPS project, Marine Frequency Converter Based Renewable Energy System in Onboard Ship. So here, with the help of our scholars, we have done this simulation. A PV system, wind and a battery system is used. So with all these things integrated, we got the output. So this is a PV system. The rating of the PV system is shown. We will be having 4 panels and a DC-DC buck boost converter. And here in our hardware, we are using a 3-level inverter. And the load which I have shown is a 3-phase induction motor. As we are having a marine we are a marine college. The three-phase induction motor is used to run the propulsion system. So we are in this system, we are used the load as a three-phase induction motor. And then the wind system we have shown 60 watts permanent magnet synchronous generator we have used, and AC/DC buck boost converter and a 3-level inverter, same concept. And then process flow of a battery system. We are in our college, we have 4 batteries of 12 volt and 150 ampere hours rating. Totally, we will be having 48 volt 150 ampere hour, and that is also connected to the buck boost converter and the 3-level inverter under the load. So this is a process flow of this hybrid power system. We have seen in the previous slide the individual systems, and here the consolidation of all these things: wind, solar, and a battery. So this is the entire rating of the system which we have erected. This is 4 solar panel I have indicated in the ratings, and this is a wind turbine we have used. This is a hybrid buck boost converter, bidirectional converter, multi-level 3-level multi-level inverter. Actually, for hardware purpose, we have used a 3-level multi-level inverter, but one of my scholar has done simulation for 13-level inverter. That also I will show you. Before that, actually, Atal is, that is AICT is organizing several faculty development programs in order to improve our learning skill to the up-to-date level. For that only, we are giving this faculty development program every year. So by that, we can utilize and we can go, we have more research opportunity in this research area. So if we go for smart grid, so in this presentation, in this slide, we can see n number of funding agencies. That is, in the we can get funding from, as we are in working in engineering colleges, we can apply for funding, and these are some of the agencies. DST is giving funding. Under DST, we have we in our college also we have applied for a FIST project, and I myself have applied for MNRE for this smart with the help of the renewable energy resources generation of power. I have applied for 30 lakhs. Still it is in review. See some of the slides, websites I will show you. So if you go for MNRE R&D portal, here this is for a renewable research and development portal. This is mainly for renewable. We can see n number of opportunities in this website. And similarly in SERB also, latestly SURE proposal came, and the power grant proposal is also there up to 18th.
இன்வைட் பண்ணது அவ வீட்லயே சமைச்சுக்குவான்னு எல்லா பிளானையும் போட்டுட்டு சேமா சித்தி அவருக்கு சமையல் செட் பண்ணி தருவாங்கன்னா எல்லாம் பேசிக்கிட்டாங்க. அதனாலதான் நான் அமைதியா இருந்தேன்.
So here in power grant, it is available up to 18th. If you want to apply, we can apply. So these are some of the and DST is also funding. Just I have shown you the 2 websites. N number of government funding agencies are there to get funding. So the government is willing to provide plenty of amount for do research in this renewable energy resources. So if we go forward, we can get funding and do the process. Sir? Sir? Uttamaran sir? Sir, conclude பண்ணிக்குவா இல்ல இன்னும் கொஞ்சம் என்னோட ஸ்டூடண்ட்ஸோட அவுட்புட்ஸ் ஏதாவது காட்டலாமா சார்?
We can have a discussion, ma'am, if there is any need. we
Okay,
can use that results later, ma'am. But
Okay,
before
sir.
that,
Okay,
we
sir.
can, if
Okay,
we
sir.
need anything, we need some conclusion.
Okay, sir. If you have any queries, please ask. Once again, I thank Uttamaran sir and the Department of EEE and Sairam Institute for giving me an opportunity. If you have any doubt, please ask.
Dear participants, if you have anything to ask, you can ask now.
Eligibility criteria for applying the proposal is, in some proposal they are asking both the PA and co-PA should be doctorate. In some proposals they are asking PA as a doctorate and co-PA can be a non-doctorate. For one proposal, I myself and my scholar, both of them have applied. So it depends upon the proposal. Maximum level up to 63, sir. Now, as of now, 63 level inverter have been used. That is for simulation purpose, not for hardware. For hardware, I think 9 level is the maximum size. If you, in a hardware, if you go for a number of levels means, again, the harmonic problem comes into role. So for simulation purpose, 63 level is implemented. And even for ladies, ladies alone can apply for a proposal. That type of proposal is also available in SERB as well as in DST. Ladies alone can also apply.
Any
Ma'am?
questions?
Yes, sir.
Ma'am, good evening, ma'am. Ma'am, actually, hardware level, how many level of inverter we can utilize, ma'am?
Sir, hardware maximum we have, that is in our college we are using 3 level. From statistics data which I have received is up to 9 level we can go. Not higher than that.
Thank you, ma'am. Thank you. Software.
Thank you, sir.
There is a question in chat box, ma'am, for foreign collaboration of proposals. What is
Yes,
the
sir.
eligibility?
Foreign collaboration, that is we have to communicate with them through a mail. If they are and foreign collaborative proposals are also available in DST as well as in MNRE. For that we have to communicate with that particular, they will be saying which country we can collaborate. So accordingly, in that country, we have to search for a university, and then in that university, you have to communicate with a person who are in that particular area, doing research in your area. If he is willing to do means, we can put a collaborative funding, sir. That is also available. Recently in MNRE, foreign collaboration is being asked. So in these websites, if you frequently search means they will give information at what date that is the funding will be closed, like that we can see and get the funding. We can apply. And these are the emerging areas where we can apply. The difference between smart grid and microgrid. That is microgrid, smart grid is a huge system. N number of microgrids put together is called as a smart grid. Microgrid is a standalone system which can supply power to that particular area or some rural area, and all we can use this microgrid. Putting together all these microgrid, integrating them is called as a smart grid. Yes, sir. At last, I will send share. Linda, sir. At last, after the session, I will show you.
Any questions?
Depending upon your area of interest, sir. In smart grid, that is as I have already told, power quality issues are there, so we can concentrate on it. If you go for a controller, IoT based controller, and if you go for stability, means stability related voltage stability, frequency stability. So n number of areas are there. So depending upon our interest and our research, we can go choose a particular area.
That is the possibility.
We can continue, ma'am.
Yes,
Can
sir.
continue.
If okay. Oh, sharing cut ஆயிடுச்சு. Sir, my screen is visible.
Yes, ma'am.
Smart green funding in India.
Okay. So based upon the RPS project in our college, she has considered a PV system, wind system, and battery, all together hybrid power system. She has used a 13-level diode clamped inverter, and with that she applied single phase load, 3-phase load, and public loads, and compare the result. So this is a parameter that is for wind. The parameters chosen are these are the values. And for solar, this is a schematic diagram of PV cell and array, and this is a detailed modeling. So she has published a paper in this. Parameters of PV is shown here. This is the last battery bank model, and she has used artificial neural network as a controller. With the help of that, she reduced the harmonics. So here in the charge controller, she applied this ANN, and also in the inverter side also she applied the ANN network. And when when wind alone is used, this is a variation in load and wind speed. And this is the voltage of the DC link which we have obtained, and the voltage at initially at time t equal to 3 seconds. This is the voltage she got. And at that time instantaneous light current and the power values. Sorry. And I will show you the paper. So second case is she has considered under unbalanced load. If you are using unbalanced load means, and this unbalanced load is simulated here, and because of the unbalanced load, what is the output? The electromagnetic torque generated output without a proposed controller and with the controller. Without the controller, the system variation is high. With the controller, lesser harmonics are there. Similarly, the line voltage and the 3-phase modulation index is shown here. When the source as well as in the load, both the sides, the variation is there, means the system performance, that is irradiance performance and the wind speed performance. And finally, the various outputs, that is PV system output and wind power output and battery, each and everything is shown in this diagram. If you have any doubt, you can ask, sir.
Any questions? You have any question, please ask now.
Ma'am, I have one question, ma'am.
Yes, ma'am.
Which one is better, ma'am? Microgrid or smart grid?
Ma'am, I have already told you, ma'am, microgrid is a subsystem of smart grid. If you go for a microgrid, we will be concentrating on any one renewable resources and getting the output, maximum efficient output towards the load. If you go for a smart grid, n number of complications has to be taken into consideration. If you are going for a research means, first we have to study what is a microgrid, and then we shall move on to a smart grid. First, we have to make a research on microgrid. What is a microgrid? What are the components? What are the things to be considered? And then next level, we shall move on to a smart grid.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Any more questions? Okay, then I will conclude the session. I would like to thank Dr. D. Lakshmi of Ahmed University for giving a wonderful presentation today. It's really interesting, ma'am. Thank you for your presentation. If you have any future requirement, we will also call you for the seminar or FDP in our college. Thank you, ma'am.
Thank you, sir. Once again, I thank management of Sri Sai Ram Institute, HOD sir, and Dr. Buttamadan sir for considering me as a resource person. And also, I thank the participants who passionately listened for this 2 hours lecture. Thank you all.
Thank you, ma'am. Thank you, ma'am. I will post the feedback link now. Please fill the feedback form. Once again, thank you all. So after submitting the feedback form, you can leave.
Sir, shall I leave?
Yes, ma'am.
Okay.
Thank you, ma'am.
Thank you, sir. Thank you, sir.
Dear all, please submit the feedback form and you can leave.
Muthamil sir, one doubt.
Yes, ma'am.
Sir, actually, yesterday I submitted the 11th day போட்டேன். இனி 10th போட மறந்துட்டேன். So இன்னைக்கு தான் வந்து 10th தட்டிட்டேன். So என்னால திருப்பி ரெஸ்பாண்ட் பண்ண முடியல. ஆல்ரெடி ரெஸ்பாண்டட்னு வருது. So what to do, sir?